We are given this function e power y plus xy is equal to e. We have to find out dy by dx and d squared y by dx square at x equal to 0. Right. First, let us try to differentiate this one once. Then we'll get dy by dx in terms of e, x, and y. We have x equal to 0. We have to find this at x equal to 0. First, then what we'll do at x equal to 0, we'll try to calculate y in terms of x and e. Right. So dy by dx, we'll write it as a function of x, y, and e. At the same time, d square y by dx square also, we'll write it as a function of x, y, and e. And when x equal to 0, we'll calculate what is y in terms of e. Right. Let us try to do this. Let us try to differentiate this. Okay, if we try to differentiate this, we want dy by dx, right? Dy by dx of e power y will become e power y into dy by dx, right? Because the differential is with respect to y, which is nothing but then this one, x, y. So if we have to use product rule, then this becomes x into dy by dx plus y into dx by dx, which is nothing but 1. Right. So the differential of this one, right side is anyway constant. So this right side differential will become 0. So this one becomes e power y dy by dx plus x into dy by dx plus y. So dy by dx, we can write this as we can take dy by dx common, right? So dy by dx into e power y plus x is equal to minus y. So dy by dx will become minus y by e power y plus x. Okay. So dy by dx we express in terms of y, x and e. Very good, fantastic. But when x equal to 0, we have to calculate this. First we have to find what is y when x equal to 0. Let us try to substitute x equal to 0 in this. So e power y, what will this become? This will become e power y plus 0 is equal to e. Right, that means e power y equals to e, that means y equals to 1. So when x equal to 0, y is equal to 1. Y equals 1. So then dy by dx will become 1 by e power 1 plus 0. That is nothing but, sorry, minus of this one, minus of 1 by e power 1 plus 0, which is nothing but minus 1 by e. Very good, fantastic. So dy by dx is equal to minus 1 by e. So these two options are wrong. Right, we have either this option or this option. Now let us try to differentiate this one again. Again, let us try to differentiate this even again to get d squared y by dx square. So again, uv function, let's take this as u. So e power y into, uh, so first function into differential of second function, that is d squared y by dx square. At the same time, so this, then second function dy by dx into differential of first function, that is again e power y dy by dx, which is nothing but dy by dx whole square into e power y. So that is the differential of this one. Now again, first function into differential of second function. So that is x into d squared y by dx square plus second function dy by dx into differential of first function dx by dx, which is equal to 1. So that is this one. So this one is giving these two terms. This one is giving these two terms. Then finally dy by dx should be equal to 0. Fantastic. So what does that mean? We have got d squared by dx square in this one now. We just need to substitute x equal to 0. We have to calculate what is d squared y by dx square. We know at x equal to 0, y equals to 1. At x equal to 0, y equals to 1. And dy by dx is equal to minus 1 by e. Right, let us substitute everything. E power y is e power 1 and d squared y by dx square plus e power 1 into dy by dx, which is nothing but minus 1 by e. Minus 1 by e whole square plus x equal to 0. This part will anyway become 0. This is anyway 0 plus dy by dx, which is minus 1 by e plus dy by dx, which is again minus 1 by e. So this one e d squared y by dx square, right? Then e into minus 1 by e, which is, sorry, e into 1 by e square. So this is nothing but 1 by e and minus 1 by e minus 1 by e, right? So this 1 by e and this one will get cancelled. Minus 1 by e will be left. So e squared, e d square y by dx square should be equal to 1 by e if we take this one to the other side. So that means d square y by dx square is equal to 1 by e square. at x equal to 0, y equal to 1. So minus 1 by e and 1 by e square. This is the correct answer. Right, guys? Simple one. We have to differentiate this one once and find out what is dy by dx in terms of x, y, and e. And when x equal to 0, we just calculated what is y. We substituted x and y. We got dy by dx at x equal to 0, 0 comma 1. Then we differentiated this once again to get d squared y by dx squared. And we substituted, we got d squared y by dx squared in terms of x, y, and dy by dx. Right. We got a second order differential equation here. And we just substituted and we got this value at 0, 1 also. Right. Thank you guys.